All right, so this is going to go through basically an overall review of what you can expect on the test, and then I'll go back through, if I don't do them now, if there's problems I skip over, I'll go back through them and work them out so that you have a video working them out for any of them that we don't get time to today. So this reference sheet's going to get given to you. You'll have a full unit circle. You'll get the law of sines, both the standard form and the alternate form. And then some of the other ones will be written directly on the problem. So if it was written on the review packet, like the angle between, that kind of stuff, then it will be given to you in the same format. I think there's, I have to double check on it, but the 30 multiple choice, 30-ish multiple choice, and then 20 open-ended, which most of those would be there's the systems of equations with 3 variables, the graphing of your conics, the rotation of your conics, all that stuff would be on the open-ended part. So the order's pretty close. It's not exact, but it's pretty close. It starts with law of sines and law of cosines. So obviously law of sines is something you need to know. It's not a formula that will be given to you. So, A over the sine of A, B over sine of B, C over sine of C, and then group them together in pairs, cross multiply, divide. Any questions on law of sines? Hopefully that should be a relatively easy one. Okay. And then 2 is the law of cosines. So remember, when they give you all 3 sides, you have to start with the largest one. Otherwise, you introduce an ambiguous case that technically doesn't exist. So for this, I would start with B. I would work through the, cosine of B equals A squared plus C squared minus B squared over 2AC. And then be really careful when you're plugging that into your calculator. Remember that you can use a scientific calculator the whole way through. Don't bring a calculator you've never used before and you're trying to teach yourself how to use it. Okay, it's obviously going to be more complicated. So that would be work backwards to get the cosine of B. Any questions on that one? Do I need to work that?
So to finalize it, it would be what you get.
Correct. So the last thing you're going to get is the cosine negative 1 from whatever you get inside the parentheses.
And then you do that in the calculator and then that's your answer.
Yep. And then that would be the largest angle, which in this case is B. And then if it says, obviously to solve, you're doing all 3 angles. The word problems, they're not going to be the exact same word problems, but there's going to be either a law of sines or a law of cosines word problems. So you want to make sure you would understand how to do those. So number 3 says, after a severe storm, 3 sisters stood in front porch and noticed that the tree in their front yard was leaning 6 degrees away from vertical. So if you're away from vertical and this is your house, right, this would be the tree. This is away from vertical means it's an additional 6 degrees, right? So what's that angle? If it was vertical, it'd be what? 90 degrees. It says, I'm sorry, toward the house. You're totally right. It says toward the house. The one on your test, I think, had away from the house. So toward the house would be 6 less, which would be 84 degrees. And then they're 90 feet away from the base of the tree, 98 feet away. They notice the angle of elevation to the top of the tree is 24 degrees. So from there, I can find the remaining angle and then find whatever side it wants, which in this case, it wants the height of the tree. So I'd be looking for that side. So this one you can actually do law of sines. Number 4 says to determine the distance between 2 aircraft, a tracking station continuously determines the distance and the angle between them, blah, blah, blah. Determine the distance A between the planes. A is 44 degrees. That shouldn't be degrees, miles. It should just be degrees. A is 44. B is 37, and C is 22. So if you wanted to know A, God bless you, you'd be setting up for the side. This would be law of cosines, right? You don't have a full pair to do law of sines with. So this is your A squared equals, and you go through that whole thing. And at the very end, make sure you remember to square root it. Okay, so that's B squared plus C squared minus 2BC cosine, right? B squared plus C squared minus 2BC cosine angle A. And then just be really careful with the calculator part of it. You don't want to get these questions wrong because of the calculator. All of these should be in what mode? degrees. Questions so far? All right, number 5, your Herons formula. So that area formula is going to be given to you exactly like this. Hopefully that avoids any mistakes that were made on the test and the quiz from this section. We're dividing by 3 or, you know, doing the equation wrong. So all you have to do is add the 3 numbers, 11 plus 7 plus 13, divide by 2 to get your S, and then do the square root of the S times the S minus A times the S minus B times the S minus C. And again, be careful with your calculator use there. Don't round your S. Keep your S how it is. Some of you round it, and then if this is multiple choice, which this is, then it's not going to match. So you want to make sure you're really careful. Okay, number 6 is component form and the magnitude of the vector. So now we get into the vectors. So remember, component form would be the x of the 2 minus x1, comma, y2 minus y1. So in this case, it's the terminal point, right, minus the initial point, 0 minus a negative 2 would be 2, and 2 minus 8 would be negative 6. Number 7 is now having functions on these. So if it says negative 2u, that's a scalar, and then positive 2v, I'm going to take negative 2 and multiply it in here. So I'd get negative 8i plus 6j, and then add that to 2 times this, which would be negative 8i minus 2j. And then you can just combine your like terms. So this would be negative 16i plus 4j. Questions so far? All right, number 8 says find the vector v that has a magnitude of 6 in the same direction of u, where u is negative 3, 2. So this is finding a vector in the same direction. You would do the component form over the magnitude. What's different this time is it says this new one also has a magnitude of 6. So once I get this, which would be in brackets, I have to multiply by 6. So 6 is my scalar here. So I would do, obviously the component form is here, negative 3, 2, and then over magnitude, I didn't finish this word, magnitude. And the magnitude is a squared plus b squared underneath the square root. So this would be the square root of 9 plus 4, the square root of 13. And then we split this. And rationalize. And then if it didn't give us a magnitude, that would be our answer. But now it's telling you that the magnitude of this is 6. So we have to multiply that in. So I'd get negative 18 root 13 over 13. And then 12 root 13 over 13. Okay, 6 said component form and magnitude. So the magnitude, when you're not given the component form, first of all, you can find your component form and then do the square root of a squared plus b squared. So that's one way to do it. I could take this and do the square root of 2 squared, which is 4, plus negative 6 squared, which is 36. So square root of 40, which would reduce to 2 root 10. Or you can do the distance formula. So the x2 minus the x1 squared plus the y2 minus the y1 squared. Oops-a-daisy. But if you've already done the component form, I mean, you might as well just go to the square root of a squared plus b squared. If not, then you can go straight to there using the distance formula. It's the same thing. All right, number 9 says find the angle between. So this is one of the ones that I'm going to give you the equation on. It'll be written right on your test. If you want to add it, the cosine of theta equals the dot product of u and v over the magnitude of u times the magnitude of v. You can ignore these. These were multiple choice. I couldn't get rid of them. So it says find the angle between them if u and v is given. So u is 1, negative 4, dot product. Do you remember what dot product is? It's been a little while. First times first plus second times second. So it would be 1 times 2 plus negative 4 times 1, 2 plus a negative 4 is negative 2. And that would go in the top. And then we just went over magnitude. So magnitude square root of a squared plus b squared. So the magnitude of u is 1 plus 16, or square root 17. And the magnitude of v is the square root of 2 squared, which is 4, plus 1 squared, which is 1, square root of 5. And then you'll have to have a calculator for this one. So this, and obviously the law of signs, are already the ones that you have to have a calculator for. You cannot share, you cannot borrow, so you need to make sure you have them. I won't be loaning them out. You need to make sure you have your own. So do what you got to do. Set an alarm or something for yourselves so you remember to bring them tomorrow. So cosine -1 of -2 over the square root of 17 times the square root of 15. And you can enter that in all at one time, or you can actually simplify, multiply the 17 times the 5 and do it that way. So second cosine square root 17 times 5. And I got 102 degrees. 102.53 degrees. Like, if I was to graph 1, 4, that means the change in my x is 1, the change in my y is -4, 1, 2, 3, 4. That vector would look like that. And then the other one is 2, 1, over 2 and up 1. That vector would look like that, which is a little bit bigger than 90 degrees, which is accurate with my 102. So you can always check to make sure that those make sense. Questions on that stuff so far? So all that's vector stuff. Okay, then we got into partial fraction decomposition. So remember, these are your, I want to take this and break it down into a sum of a bunch of fractions, one for each term in the bottom. So once I factor this denominator, I'd get x, God bless you, times x squared minus 1, which is x times x plus 1 times x minus 1. That's 3 terms. That means I have to divide this into 3 fractions. So 5x squared minus 3x minus 4 over x times x plus 1 times x minus 1 would equal a over x plus b over x plus 1 plus c over x minus 1. And then one at a time, I need to multiply out what's missing on the bottom. So from a, the denominator would be missing x plus 1 and x minus 1. From b, x and x minus 1. And from c, x and x plus 1. And then I write out just my numerators. And then one at a time, I got to cancel these out. And really, it's going to cancel them out 2 at a time. So let me start with this one. I can plug in a -1 here to cancel out the a. So if everywhere there's an x, so 5 times -1 squared would be 5 times 1. This is 5 plus 3 minus 4, 8 minus 4, which is 4. This would be 0, so the a is gone. And this would be 0, so the c is gone. And then the b is -1 times -2, which is a positive 2. Divide, and b is 2. And that's the first one. With me so far? Okay, then I've got to cancel out the b. So I can either plug in a 0 or a 1. Let's start with the 0. It makes it a little bit easier. So if x is 0, then I get 5 times 0 squared minus 3 times 0 minus 4. So everywhere there's an x, I made it a 0. This is gone, this is gone, this is -4. This is a times 0 plus 1, which is 1, times 0 minus 1, which is negative 1. So that's a negative a. This 0 cancels that whole thing out. That 0 cancels that whole thing out. So a is positive 4. And then I want to cancel out the last one. I can put in a 0 or a negative 1, and I've already done the 0. That should be a minus. Where's the minus one? What I haven't plugged in yet, I need to keep the C, not cancel out the C, would be the positive one. So now everywhere. So this is 5 minus 3 minus 4, which is 2, minus 4, negative 2. This is a 0 here, so the A is gone. This is a 0 here, so the B is gone. 2 times 1, so that's 2C, and C is negative 1. And then I've got all of my numerators to plug back in. So I come back up here. I think this is on the multiple choice portion. I can't even remember. So it will be written as your original. And then A is 4 over X. B is positive 2, right? Yeah, positive 2 over X plus 1. And C is a negative 1. The negative goes in between 1 over X minus 1. And if you've got time, you work backwards to check them. All right, hopefully it gets a little bit easier with some of this stuff that we've seen a lot. Systems of equation. And it says by substitution, if it's multiple choice, I'm not checking your method. So do whatever method is easiest for you. If you're better at elimination than you are substitution, then do it. It's just they're not all multiple choice. Like the 3 variable 3 equations are not the multiple choice ones. Those are the ones that you have to do a lot of work to get to, okay? So if I was to choose here, I would probably do elimination. I would multiply this by negative 1, so I'd get negative x plus y equals 3. And then combine these, x squared minus, this is not an x squared, this is just an x. These are gone, equals 2. So x squared minus x minus 2 equals 0. And then we just reviewed solve by factoring, right? So 2 and negative 1. And then you've got to take each one of these and plug them back in. So if I take a 2 and plug it in, 2 minus y equals negative 3, negative y equals negative 5, y equals 5. That's my first one. And then take the negative 1 and plug it back in. Negative 1 minus y equals negative 3. Negative y would equal negative 2, and y would equal positive 2. And those are your two solutions. 12, same. This one's not quadratic. You just have to get rid of the fraction. So I multiply everything by 12 to make it easier. X, this would be 4 times x minus 2 plus 3 times y minus 1 equals 1. 4x minus 8 plus 3y minus 3 equals 1. 4x plus 3y, and that's negative 11. Move it to the other side, and I get 12. And then I would multiply everything by negative 4, get the x's to cancel out, and plug it back in. I would just get rid of the fraction as soon as you could. 13's your do I need to finish that one, or you guys okay on systems? You okay? All right, 13's your triangle system where you start bottom up. This is your back substitution. So I'm taking the z, I'm plugging it back in here. 6y minus 5 times negative 6 equals 12. 6y plus 30 equals 12. 6y would equal negative 18, and y would equal negative 3. And then this goes into the z, and this goes into the y. So 4x plus a 9 plus 12 equals 21. 4x would equal 0, and x would equal 0. And then I got 0, -3, -6 is my solution. All right, so 14, and I only gave one system, but that's technically two questions, and they're worth actually, so there's 47 questions, and 3 of them are worth 2 questions each. That's one of them. So, or that's actually 2 of them. The Gauss-Jordan is your matrix. Okay, so your 1s, 0, 0s, and your zeros and all that stuff. The Gauss-Jordan is the one that you want to work to get 1, 0, 0, 0, 1, 0, 0, 0, 1, and then the numbers here. So remember, goal-wise, you would want to get the 1 on the top left first. It makes your life a little bit easier. Work your way down, get the 0 in the next spot. Work your way down, get your 0 in the next spot. Work your way over. And then these 3 do in whichever way makes sense to you. Sometimes I work up and over, but most of the time, sometimes it's obvious to do one way or the other. So that's your Gauss-Jordan. Okay, so if you want to go back to chapter 7, that's where all that stuff is. And then the Kramer's rule is the one that we learned later on when we learned determinants. So remember Kramer's rule, you have to find d sub x, you have to find d sub y, d sub z, and d. And you do that by doing the matrix. So this, you do the x, y's, and the z's. And then the rest of them, you take out that variable and you plug in the constants. So for the x's, I would take out and put in the constants, the x's, and then the y's and the z's would go. For the z's, I would take out the z's and put in the constants. And for the y's, I would take out the y's and put in the constants. Yeah. So I'll work through, let's do d of x because it's good to do the determinant. So you're going to do the determinant here, and then there's a question just on the determinant. So if I'm doing the determinant to find d sub x, let's say, then I take all the constants, so I would rewrite this first as a matrix. So 4, 1, 2, 13, 8, 3, 6, 35, and 6, 4, -2, 22. So to find d sub x, I'm going to take out the row of d's and put in the constants, which is that last column, 13, 35, 22. And then I do the y's, 1, 3, 4, and the z's. And then to find the determinant of a 3 by 3 matrix, remember you repeat the first 2 columns to the right. And then I multiply top left, bottom right out. So 13 times 3 times -2, that's -78. 1 times 6 times 22, that's 132. 2 times 35 times 4, 280. And then add those together. God bless you, I get 334. And then go backwards. So 2 times 3 times 22. 13 times 6 times 4. -2 times 35 times 1. And then you always do the first minus the second. So some of you switched that when we did quizzes and tests, so be careful. 334 minus 374. And d sub x is -40. I would go through the same process to find d sub y and d sub z, and then I have to put them all over whatever d is, so I'll do d real fast. D is just the x, y's, and the z's. repeat your columns again, the first two columns. Be really careful with your signs because that's how a lot of people make mistakes. So I'm going to go this way first. And then come back this way. So 76 minus 116 is negative 40. And then I work through to find d sub y and d sub z, but just to show you just this one, to get the x, y, z, to get x, I do d sub x over d. To do y, I do d sub y over d. And to do z, I do d sub z over d. So just already, I know that the d sub x over d would be negative 40 over negative 40, which is going to be a positive 1. And then I would repeat the process for d sub y and d sub z and put it over d to get the remaining. I think that's like a 132 answer or something like that, 152, something like that. All the answers are at the back. You guys saw that, right? Yeah.
Wait, so how would you like finish the answer again? Like,
so that's just x, but then I would, and I can go through and do it now. I would do d sub y. So y, I take out the, oh, I'm copying down the wrong one. I take out the y's, so I would leave the x's. I take out the y's and put in the constants. And then I duplicate the columns to the right again. And then I go top, bottom, top left, bottom right, all the way down. 4 times 35 times negative 2. 13 times 6 times 6. 2 times 8 times 22. And I get 558. And then go the other direction.
so would the final answer be, like in parentheses, x comma y comma?
Exactly. Which just did something wrong, right? All right, so that should have been 468. Okay, so then that d sub y is negative 200. So d sub y, or to get y, I would put d sub y negative 200 over negative 40, and I get 5. That's the y, and then I'll repeat the process for the x, I mean for the z, sorry. Get the z, and then what do we say? It should be 153. Should have been your answer at the end. 52. So whether you do it Gosh Jordan or you do it Kramer's Rule, you should get the same answer. There'll be different questions on your test, so just make sure you know how to do both. I gave you the same system so you didn't have to get 2 different answers. Like, you can kind of compare them. Questions on any of that? That's a long one. So my advice is leave those long ones for the end. They're pretty much towards the end of the order anyways, but watch your time and don't leave them blank. Those questions blank is 2 questions. The idea behind them being on the partial credit part is you can get partial credit. So don't leave them blank. Otherwise, you're already, docking yourself for 8 points right off the bat. At least give yourself some partial credit by trying it. Okay, and then I'm going to zoom back in on this one. Adding and subtracting. So now we're in adding and subtracting matrices, multiplying, all those things for matrices. Remember, you can only add or subtract if they have exactly the same dimensions. So these are 2 columns, 3 rows, no, 2 rows, 3 columns. So they're both that way, which means you can find this function. So the 3a means I'm going to multiply 3 in on all of these. So 6, -6, -18, -3, -27, and -6. And then I'm going to do 2 things. One is I can multiply in a positive 2 and keep the minus between them. So if I did that, this would be -16, this would be -12, this would be -4, this would be -6, this would be 8, and this would be -14. So if you multiply in the positive 2, then the negative stays between them. And then I do 6 minus a -16, which becomes 6 plus 16, or 22. -6 minus a -12 becomes -6 plus 12, which is 6. -18 minus a -4 becomes -18 plus 4, which is -14. 3 minus a -6 becomes -3 plus 6, which is 3. -27 minus 8 is -35. And -6 minus a -14 becomes -6 plus 14, which is a positive 8. That's one way to do it. The other way is distribute in a -2, so take the negative with it, but then the sign in between would change to positive, so you'd be adding them. It's exactly the same answer, just be really careful with your negative signs. This should be an easy question. You don't want to get this wrong because of the negatives. Questions on adding subtracting matrices? Okay, 16 says, if possible, find A, B. So now we're multiplying. So do you remember the rules on multiplying? First thing to do, figure out the dimensions, right? So this is a what? A 3 by 3, and this is a 3 by 2. So what's the rule on multiplication? All right, so rule is outside has to match, and the inside would be the result. So these don't match. These don't match, which means you can't multiply it. If you did, let's say that those were switched, then you would set it up that it was a 3 by 3, 1, 2. And I would go cell by cell. So this is row 1, column 1. I multiply everything in row 1 times column 1. Then I would go row 1, column 2, row 1, column 2, multiply and add them up. And then I would go row 1, column 3, row 1, column 3. There's no column 3. That's how we know there's nothing to multiply by. Okay, but if this was reversed, if it was a 3 by 2 times a 3 by 3, it'd be totally fine. So if I had asked you to do B times A, you could do it. So be really careful, okay? All right, number 17 is find the inverse of the matrix. So remember, the easiest way to do it is that determinant. You would do 1 over the determinant times, and you would switch. So if this is A, B, C, D, then you switch A and D. So you switch the locations on A and D, and you negate B and C. Change the signs on B and C. This is a really bad example because it's the same either way, but we'll walk through it. So we do the little fish to get the determinant, which would be 4 times 4 minus 1 times 1, 16 minus 1, which is 15. And then I would put 1 over 15 times, and I switch these two, which sadly are the same this time, but 4 and 4. And I negate these two, which again, that's why it's a bad example, would give me the -1, the -1. And then distribute that in. So I'd get 4 over 15, -1 over 15, -1 over 15, and 4 over 15. Questions on those? Okay, determinant is the one we already did, so I would repeat the 2 columns to the right, and then top, bottom, or top left, bottom right first, and then bottom right, top left, going back the other way. And then do the first minus the second. So that's the same thing from the Cramer's rule.
So the switching and then the other side switching, or no, the
inverse one?
Yeah, that only works with
a 2 by 2, which I won't ask you for an inverse of a 3 by 3. So let's just say it was like this so that we can actually show the difference, right? So if I was asking for the inverse of that, that would be 2, for the determinant, 2 minus a negative 12, which would be 2 plus 12, that's 14. So I do 1 over 14 times, I switch the 2 and the 1, so that becomes 1 and 2, and I negate the negative 3 and the 4, so this becomes a positive 3 and a negative 4. And then I distribute that into each one. Questions on any of the matrix stuff, because then we get into the series and all that good stuff. Okay, number 19, first 6 terms defined by the function. Hopefully, do I need to work through this one? This is if n is 1, and then n is 2, and then n is 3, and then n is 4, and then n is 5, and then n is 6. I threw some on there like that, super easy. Hopefully, you can figure that out, right? Questions on that one? All right, write the first 5 terms of the geometric sequence. So the R, remember geometric is you're multiplying by the same thing every time. So the common ratio, right? So if the common ratio is 2, then I'm going to take 8. I'm going to multiply it by 2, get 16. But 8 is my first term. So be really careful because this is multiple choice. You're going to get it all the way wrong if you start with 16, and you shouldn't. Okay? So then I would do 16 times 2, 32, and then 32 times 2, 64, and first 5, and then 1, 28. That would be the first 5. Make sure you include the first one they give you. That should be a super easy question. Yep. 21 is simplifying the factorial. So remember, this is 6 times 5 times 4 times 3 times 2 times 1, but we want to stop at the smaller factorial over 3 factorial. And we can cancel these out, multiply that together. 30 times 4 is 120. Or those of you that scientific calculators have your little factorial, you can use it. Okay. The sum on a finite set like this, I start at the bottom and I stop at the top. So this would be 2 times 1 minus 2, I find that, and then 2 times 2 minus 2, I find that, 2 times 3 minus 2, 2 times 4 minus 2, 2 times 5 minus 2, and then I add them all up at the end. So this is 0, this is 2, this is 4, this is 6, this is 8, and then I add them all together at the end. '23 is just like that. So same thing, start at the bottom, work your way up to the top. Just remember that if it's not 1 at the bottom, you have to like adjust your top. So if it goes 0 to 5, then you're doing 0, 1, 2, 3, 4, and you're stopping at 5. That's your upper bound. That's where you stop, not how many there are. Number 24 says determine whether the sequence is arithmetic. Arithmetic means you're adding the same thing every time. So geometric, multiplying, arithmetic, adding the same thing every time. So from 7 to 12 and 12 to 17 and 17 to 22 and 22 to 27, are you adding the same thing every time? Yeah. So this is yes. And the common difference, which is represented by D, is what? What are you adding every time? 5, positive 5. Where were we on time? Okay, infinite series. Oh, let me see if this is one that I... All right, so I'll give you that one, the infinite series. So the little formula for the infinite series, if your series is this summation symbol with the infinity on the top, it should start at 0. In this case, well, it should start at 0 and at k, and this one is k minus 1. So actually, I'll adjust the way that it's written so as not to confuse you. And then it's a, and this is r, right, to whatever the power is. So the a is what's in front of the parentheses, the r is what's being raised to the power. The rule with the infinite series is that absolute value of r, so you're ignoring the sign on it, has to be less than 1. Remember, that has to be a fraction in order to be able to find the infinite series. So this, whatever's being raised to the power, has to be a fraction that's smaller than 1, which this case it is. And then the equation is a over 1 minus r. So the a is on the front. 1 minus 1/10, this becomes 10/10. This becomes 4 over 9/10, and then keep change flip. And you get 40 over 9. I think this is actually in decimal format. I can't remember. Maybe not. It'll either be written like that or it's 4.4 repeated. Yeah, no, it stays exact. Okay, arithmetic. Where are we at on time? Okay, we're okay. So do you remember how to find a sub n if it's arithmetic? Do you remember this? Starts with a sub 1. There's a d involved here. Good. And you can put it as a, right, I had you guys write it as a sub 1 first, right? A sub 1. Okay, so here's your a sub 1, here's your d. This is 102 plus negative 8 times n minus 1, 102 minus 8n plus 8, and a sub n would be 110 minus 8n. That one's not on there, so you want to make sure you remember that one. All right, 27, arithmetic sequence. So I'm taking negative 0.7 and I'm adding it on to negative 0.25. So I'm subtracting 0.7 each time. So this again, first one, make sure you include that. And then negative 3.2, negative 3.9, negative 4.6, negative 5.3. All right, all of that was chapter 8. Then we got into permutation combinations. So P is what? Hopefully we remember the difference between them. Permutation, combination. P is permutation, right? What's the difference between a permutation and a combination? Two little words. Order matters, right? Order matters with permutation and not with combination. So if I'm trying to figure out how to put things in any order, then permutation is what you're looking for. Okay, this is, the formula for permutation is n factorial over n minus r factorial. The n is the first number. This would be 7 factorial over 7 minus 4 factorial, 7 factorial over 3 factorial, and then we reviewed how to simplify that out. Again, you can use calculator if it has the exclamation. Okay, C is the combination, formula for combination, which, and neither of these are on there, so make sure you know these. Combination, so if it's nr, is n factorial over n minus r factorial. It starts the same way, except that you multiply it times r at the end, r factorial. So this would be 8 factorial over 8 minus 6 factorial times 6 factorial. So again, you would just simplify this out, 8 factorial over 2 factorial times 6 factorial, and then break that down. So that would be 8 times 7 times 6 factorial over 2 times 1 times 6 factorial. These are going to cancel. 2 goes in 8 4 times, and this would be 28. Or let your calculator do the work if it's got the exclamation mark. Number 30 says find the set of parametric equations for the rectangular equation. So it's giving you what t is, but you need an x and a y. So I want to just solve the first one for x. So I would subtract the 2, t minus 2 is equal to negative x, and then x would equal to negative t plus 2, or 2 minus t for x. And then you've got to take what x equals and plug it in the place of the second equation, and then solve for y. So negative t plus 2 equals 4y minus 3, and then add the 3. Negative t plus 5 equals 4y, and divide by 4. So negative 4t plus 5 fourths equals y, which will probably be written so that the first term's positive. So that's parametric equations. Number 31, graph the hyperbola. So remember with a hyperbola that whatever's with the x and the y, well, with any of the conics, would be your center. In this case, the center would be 0, 0. Whatever comes first in the hyperbola is the axis. That's going to be the major axis. So this is the x-axis. This is going to be a horizontal hyperbola. And whatever's underneath the positive term or the first term is going to be your a. So a squared is 16, making a 4. B squared is 36, making b 6. And that's the distance from the center. On the A would be the horizontal axis in this case. So center's here. We would go out 1, 2, 3, 4, and go out 1, 2, 3, 4. And then the vertical axis is the minor axis this time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I should actually be doing this on the graph I provided for you. So let's do that here. So center 0, 0, over 4, up 6, and down 6. And then imagine there's a little imaginary box there. And the asymptotes are going through the corners of that. And then the hyperbolas are going to be as wide without touching those asymptotes as possible. So it looks something like this. Okay, now we're on a parabola. So remember with the parabolas, there's only going to be one squared, and whichever variable squared is what determines which way it faces. If it's an x squared, then it opens up or down. If it's a y squared, then it opens right or left. So this is a y squared. It's going to open right or left. And then I want to get the squared on the same on the side by itself. So I'm going to send the other part to the right-hand side. And then the standard equation for the parabolas are x minus h squared equals 4p times y minus k, or y minus k squared equals 4p times x minus h. So in this case, the hk is my center, which would be a 4, 2. I'm in my vertex, sorry. And then this is positive, which means it's going to be pointing to the right. If it was negative, it would point left. And 4p equals 4, which makes p 1. So my vertex is 4, 2. I plot my point, and then this is pointing to the right. So my focus would be 1, whatever p is, to the right. And my directrix is going to be p to the left. So this is my graph. And the focus would be here at 5, 2. 33, select the coordinates of the circle center and its radius. So center and radius come from standard form of a circle, which is x minus h squared plus y minus k squared equals the radius squared. Take the opposite again of what's inside. So the center would be 9, negative 5, and the radius would be the square root of 36, which is 6. That would go there, those blanks. And then graph it. So 9, negative 5 means I would have to go 6. I'm actually going to make these 2s. 2, 4, 6, 8, 10, 9, and then this would be negative 2, negative 4, negative 6, negative 8. So I'm down here. And then I would count 6, which every tick mark we just said was 2. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And my circle looks something like that. Number 34, sketch the graph of the ellipse. So with an ellipse, actually with hyperbola, ellipse, all of that stuff, the first thing you want to do is get this 36 to be a 1. So I've got to divide each term by 36. This would be x squared over 9 plus y squared over 4 equals 1. So remember with an ellipse, just like a hyperbola, the center is going to come from the numerator. So the center here is 0, 0. And whatever's larger with an ellipse. So A is larger with an ellipse. It's first with a hyperbola, larger with an ellipse. So A squared is 9, which makes A3. And B squared is 4, which makes B2. So center being at 0, 0. Whatever variable A is under is the major axis. So because the A, the larger of the two, is under the X, I know that it's larger on the X axis, which means from that 0, I'm counting right and left 3 and up or down 2. And there's my, pretty messy, but that's the ellipse. All right, number 35, determine the angle theta through which the axes are rotated and round your answers to 2 places. So this will also be on your test, but for the rotation of the angle, it's the cotangent of 2 theta equals A minus C over B. So all this wants is the angle. Remember, the A is what's in front of the x squared, so it's A x squared plus bxy plus cy squared, and then the rest of that, which we don't need. We just need the A, the B, and the C. So A is what's in front of the x squared. In this case, A is 1. B is what's in front of the xy. B is 2. And C is what's in front of the y squared. In this case, it's 1. 1 minus 1 over 2 is 0 over 2, which is 0. So the cotangent of 2 theta equals 0. So what we need to figure out is where, if the cotangent is 0, then the tangent would be undefined. And you look at your unit circle and you would find that the tangent is undefined at the pi over 2 location, because of the y over the x would be 1 over 0, which is undefined. So if 2 theta equals pi over 2, and I divide both sides by 2, then theta is pi over 4. Which is the same thing as 45 degrees. So that's all that one's asking for. The next one says rotate the axis to eliminate the xy term in the equation, and then write the equation in standard form. So now I'm going to do 36 and 37 here a little bit on the bottom, so that they are both rotation of the conics. Okay, this is a little bit more work. So this is another one that's going to count for double the point value. So xy plus 3 equals 0. So the first thing you've got to do is find out what theta is. So A is 0, and C is 0, and B is 1. And then A minus C over B, so this would be the cotangent of 2 theta equals 0 minus 0 over 1, which is 0. So again, we're looking, if cotangent is 0, then tangent would be undefined. And that's going to occur at pi over 2, so 2 theta equals pi over 2, and divide by 2, and theta is pi over 4. So now we know what theta is, and then we've got to find x and y. So the x equals the x cosine of theta minus the y prime cosine, sine of theta, and the y equals the x prime sine of theta plus y prime cosine of theta. So at theta, which is pi over 2, pi over 4, the good news is both the x and the y are the same in this case. So I would say x equals x prime times the cosine of theta, which is going to be root 2 over 2, minus y prime times the sine of theta, which is root 2 over 2. And I'd get root 2 x prime minus root 2 y prime over 2. And that's going to be your x. And then repeat that process for y. So y would equal x prime times the sine, which is still root 2 over 2, plus y prime times the cosine, which is root 2 over 2. So y equals, this time it's root 2 plus root 2 over 2. X prime, y prime. And then we have to take our equation, that xy plus 3, and we have to plug these x and the y back in the place of them. So x was root 2 x prime minus root 2 y prime over 2 times root 2 x prime plus root 2 y prime over 2, because that's the y. And then add 3. Set it equal to 0. So I would multiply these out. This is actually the difference of 2 squares in the top, so I can save myself some work. I square the first term, which I'd get 2x prime squared, square the second term, minus 2y prime squared over 4 plus 3 equals 0. I would bump the 3 to the other side because at some point you need to get this in standard form. So I would get the same thing, negative 3 over here, and then get rid of your denominator by multiplying by 4. So 2x prime squared minus 2y prime squared equals 12. And then the last thing you've got to do is get it into standard form. So I'm going to divide everything by 12. And I get x prime squared over 6 minus y prime squared over 6 equals 1. And that's all 36 asks for, is just to write the equation in standard form. So for 36, we're done. But for 30, so we're changing number 37 so that it says x squared minus 18xy plus y squared equals 16. I think this will work. We're going to try it out. All right, so this is your rotation of your conics. So you've got to eliminate your xy axis. I'm going to give you the cotangent to theta equals a minus c over b. I'll give you that, and I'm also going to give you that x equals x prime times the cosine of theta minus y prime times the sine of theta, and y equals x prime times the sine of theta plus y prime times the cosine of theta. So hopefully you remember the a is what's in front of the x squared, so in this case a is going to be 1. The b is what's in front of the xy, which in this case is negative 18. The c is what's in front of the y squared, which is in this case 1. So I would do that the cotangent of 2 theta equals 1 minus 1 over negative 18, or 0 over negative 18, which is 0. And then you'll also get a unit circle. Okay, so from that, cotangent of 2 theta is 0. And so if cotangent is 0, what's tangent? What's the reciprocal of 0?
1. Negative 1.
If 0 over 1 is 0, what's the reciprocal of that?
Undefined.
Aha, God bless you. So we're looking for where on my unit circle tangent's undefined. Usually we look in that first quadrant unless the sign's not positive. And it would be at pi over 2. So I'm saying that 2 theta equals pi over 2, which means theta equals pi over 4. So that's step 1, find the angle. This question, so I'll tell you which ones are worth 2 questions. This one's one of them. This one, the Jordan or Gaussian elimination with back substitution is worth 2 questions. And the Kramer's rule is worth 2 questions. There's a lot of work that goes into those, okay? So everything else is worth, there's 50 total questions. So they're each worth 2 points. These would be worth 4 points. My advice on these is don't leave them blank. They're open-ended for a reason. They're open-ended so you can earn partial credit, okay?
Do we have multiple choice?
Yes, there's 30 multiple choice, and then technically 17 open-ended, but of those 17, 3 of them count for 2. Does that make sense? Yeah. Okay. All right, so from here, once I find the angle, then I've got to do the x and y, this part. So I would say that x equals x prime times the cosine of pi over 4 minus y times the y prime times the sine of pi over 4, and y equals x prime times the sine of pi over 4 plus y prime times the cosine of pi over 4. And then you'll have your unit circle, but hopefully there's things that you can do quickly, like pi over 4 would be root 2 over 2 and root 2 over 2. So they're the same. So this is going to be x prime times root 2 over 2 minus y prime root 2 over 2.
Do you have the 2 over 2 over 2?
What do you mean?
On our exam, like, is it the pi over 4?
Maybe. There's more than one version. And then y would equal x prime times root 2 over 2 plus y prime times root 2 over 2. x prime root 2 plus y prime root 2 all over 2. And then we take those and we plug them back into the original equation in place of the variable that's there. So x squared is x prime root 2 minus y prime root 2 over 2 squared minus 18 times x times y plus y squared equals 16. And then we've got to simplify these. So we can use that like a plus b squared. If it's a perfect square, then the first term is a squared, the last term is b squared, and the sign from the middle, or the 2 in the middle would be 2a times b to do this and to do this. If that shortcut gets you, then expand it and FOIL it out. So if I use a shortcut, I'm squaring this, which would be 2. I'm going to lose the primes and bring them back at the end, okay? Just don't forget to bring it back, that's all. And then multiply these two together, double it, I'd get negative. So root 2 times root 2 is 2. 2 times that is 4xy. And then square the last one, which would be 2y squared. Again, I'm losing the primes now, but I'll put them back at the end. And then square the 2 on the bottom and I get 4. Minus this is the difference of 2 squares. So that's just a squared minus b squared in the shortcut, which would be 2x squared minus 2y squared over 4. And 18 still in the front. And then the last one is just like the first one, except it's a plus in between. So 2x squared plus 4xy plus 2y squared over 4 equals 16. And then I would get rid of the 4's. So everywhere there's a denominator, it's going to cancel, and I'm going to multiply this times 4 over here. So 2x squared minus 4xy plus 2y squared minus 18 times 2x squared minus 2y squared equals 64. Distribute this. I know. 4 points. So at least get somewhere, right?
If you got up to there.
If you got up to there, I'd probably give you like 3 points. Yeah. All right, then the goal here is to cancel these out, right? So these are gone. And then combine all your x squared, so negative 32 x squared. Then combine all your y squareds, y squared, y squared, y squared. And then it's a conic, so I've got to get it equal to 1. I mean, equal to 64, sorry. Oh, that should have been a negative. This needed to be a negative 16. Negative 16. So I'd get x squared over 2 minus x prime. Y squared over 2 equals 1. That should have been negative. Okay, so the primes come back at the end. Just make sure that you know that this is rotated on the axis. So if it's a, oh, and this is plus. So if it's a plus and it's the same, what kind of conic is this? Minus is a hyperbola, yes? Yes. Plus with different a's and b's would be an ellipse. Plus would be an ellipse. And if they're the same, it's going to be what? What would be an ellipse that goes up and down the same as it goes left and right? A circle. Okay, so this is a circle. If I wanted to multiply back by 2, I would get x squared plus y squared equals 2. So this is a circle with a radius of the square root of 2, which is about 1.4. But it's a rotated one, right? So we have to rotate the axis. We said the angle was pi over 4. So this is now my axis, and I'm going to go out 1.4 in each direction. So the ultimate goal here is obviously the graph, right? But get yourself as far as you can get. There is a question that just asks for the angle, which there's one in here like that, where you get to the pi over 4, you'd be done. Okay, and then there's the one where you've got to go a little bit further and you've got to graph it. That's why it's worth more points. Okay? Mm-hmm. Okay. Any other questions on the rotation of the axis? Okay, 38 says graph the polar coordinates. And here is your A and your B. So this is your radius of 2 and your theta, which is 2 pi over 3. So on your unit circle, 2 pi over 3 would be this line here, and then it's a positive 2, so you're going up 2 places, and that would be your point. And then it says convert the point to rectangular coordinates. So to go from polar to rectangular, you do r times the cosine of theta, comma, r times the sine of theta. So the cosine at 2 pi over 3, this would be a negative 1/2 and root 3 over 2. And I'd get 2 times negative 1/2 and 2 times root 3 over 2. And I get negative 1 and root 3. It's different than on the key, so make sure that you mark that one because that one's the right one. 39 says graph the polar equation using symmetry, zeros, maximum, r values, and any other additional points. So hopefully this is an easy one because r equals 3 is just a circle with a radius of 3. So I'd go up, down, left, right, in all directions 3. There's symmetry to the polar axis, the pi over 2, and the origin on this one, but you don't need it. You only need to know that that's a circle. All right. So the 38, the answer in the answer key is wrong. So make sure you make a note of that. Okay. That says. I don't need to be recording that. Make sure you also review the other types of polar equations. I did not go hard on you, but it could be a rose, or it could be one of your, I didn't do a lemniscate, it could be a cardioid, or one of those. Just make sure you understand symmetry enough to get you somewhere, right? So it could be rose, and so those would be something with something in between. No, that's a lemniscate, so I didn't do a lemniscate. Yeah, so this could be something in between here would be a rose. Remember, and if it's even, then it's double the amount of petals. So this would be a rose with 4 petals. If it's odd, then it's the exact amount. So this would be 3 petals. Okay. Any other questions overall on the content? Because I'll go back through.